AC and DB, the diagonals, which I'll draw in right now, bisect each other. And if they bisect each other, it means that this point, which we'll just call E, is the midpoint for both of the diagonals. And so we can cut through a couple of the things that we already know based on the other properties of parallelograms. So for instance, we know that AB is congruent to DC. So let's keep track of these over here. So we know that AB is congruent to DC. Okay. We also know that since, and we can mark these if we want, we know that that's parallel to that and that's parallel to that, right? So because those lines are parallel, we also know that angle 1 is congruent to angle 4 and angle 2 is congruent to angle 1. So let's write that. So we have angle 3 is congruent to angle 4 and angle 1 is congruent to angle 2. And all of that is because that's the definition of a parallelogram. Okay? So now the second thing we need to do is, our goal is to prove that these segments are the same. So we're going to start again with triangles, right? Prove the triangles are congruent. So we want to prove that ABE is congruent to CED, and I already can because I have angle, side, angle matching up with angle, side, angle. So we've already done enough to prove those triangles are congruent, so I'm going to write that down. So triangle AEB is congruent to triangle, let's match that up, right? CED, and that is because of angle, side, angle. So we know those are congruent. So if they're congruent, then we know all pairs of corresponding parts are congruent. So for instance, I know that AE is congruent to EC, so I'll write that down. So AE is congruent to EC. And I also know that DE is congruent to EB. So DE is congruent to EB. And I know that because all corresponding parts of congruent triangles are congruent. So what that means, right, is that if AE, just changing colors real quick, if AE is the same as EC, then E must be the midpoint. So E is midpoint of AC. And if DE is the same as EB, then E must also be the midpoint of DB. So, and DB, both of those segments, E is the midpoint. Because that's the definition of a midpoint. It's the point that splits a segment into congruent pieces. So finally, and that was 4. So finally, if that's the midpoint, then that line is getting bisected because that's what a bisector does. It cuts a line or segment through its midpoint. So again, if E is the midpoint of AC, then DB must be bisecting it. And if E is the midpoint of DB, then AC must be bisecting that. So we can say that AC and DB bisect each other because they both pass through the midpoint, and that's the definition of a bisector. Okay, so we just proved that if you have a parallelogram, any parallelogram, the diagonals cut each other in half. They bisect each other. So now let's just apply some of the properties that we know. In this case, we're finding the values of x and y. X and y, so we can start with x, right? So for x, we know that that length has to be the same as 12 because opposite sides are congruent. So we know that x plus 4 has to be the same as 12. So x has to be 8. So that's pretty simple. And then it turns out that y is even simpler because opposite angles are congruent. So y is 65. So that is about as easy as it gets. Next, the diagonals of LMNO, parallelogram, intersect at point P. What are the coordinates of P? Well, we know that the P has to be the midpoint of both LN and OM. So you can actually pick either one and just find the midpoint coordinates. And I'll just point out this. If you did L and N, that's fine. But if you pick O and M, notice that O is the origin. So you're going to have 0, 0 as one of your points, which is really easy to work with. So I'm going to do that. 0, 0. And M looks to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So 7, 4. Okay, so the midpoint is the average of the x values, 7 plus 0, and then the average of the y values, which is 4 plus 0 over 2. And so that is just 7 divided by 2 is 3.5. And 4 divided by 2 is 2. And so we should see that 1, 2, 3.5, 2, perfect. So we know that it should be 7 halves and 2, and that is it. And just notice, last thing, it didn't matter. If you wanted to pick n, so it's at 1, 2, 3, 4, 5, 6, so 6, 0, and L, 1, 1, 2, 3, 4, 1, 4. You're still going to get exactly the same thing. The midpoint of that has to be the average of the x values, 1 plus 6 divided by 2, and the average of the y values, 4 plus 0 divided by 2. So that's 7 over 2 and 2, which is exactly what we got. So either way, you're going to get the same thing. It's just I chose to work with this because 0, 0 is very convenient to work with. Last one, another pretty simple example. May not look like it at first, but we'll walk right through it. So find the value of the measures in parallelogram J, K, LM. So NM. NM is really easy because KM is a diagonal and it is getting bisected. So I know that NM is the same as KN. So if that's 2, then this is 2. And then KM is just the whole, so that has to be 4. And then the measure of JML. So JML is JML, right? So we're looking at, change the color, we're looking at this whole angle right here. Well, I know that this angle plus this angle has to add up to 180 degrees. So I know that JML plus 110 has to equal 180. And so if I just subtract the 110, I know that the measure of JML has to equal 70 degrees. So that's pretty simple. And then KML, again, switch colors. So KML is just this part right there, right? So KML. Well, I know that measure of KML plus 30 is 70. So then what's left is 40 degrees. So KML is 40, JML is 70, NM is 2, KM is 4.